And
That
everybody's flooding in. Perfect. Awesome. All right, good news. All right, thanks for joining us. I will quickly introduce Dr. Eric. He's going to give us an overview of herbicide resistance in the Southeast USA, and we'll take it off there.
Oh, thank you very much, Jamie. I guess let me try to share my screen, correct?
Yes, please.
Okay, I'm gonna minimize my video. You don't want to see that hideous. You'd rather see my slides. So let's I just want to make sure, can you confirm that you do see my slides?
Yes, we're good. Thank you.
All right. Well, I appreciate the opportunity to visit with you today to talk about herbicide resistant weeds. It's something that I've been working on for over 20 years. We have Palmer amaranth problems and Italian ryegrass problems. So in my presentation today, I'd just like to provide you with a general overview about what herbicide resistant is, weeds are, and where we stand in the world, and specifically in Canada a little bit. But more importantly, I want to share with you what we've been doing at the farm level with growers to try to help them manage herbicide resistant weeds. First, I want to give you a little more background about what I do, because we've had a diverse array of speakers today talking to you, and I'm pretty different from everybody else, I think, in many respects. But just to give you a brief overview of what I do and why that matters, because our agricultural systems here in South Georgia are different than a lot of other places. First, just to give you a little review about U.S. geography. If you're not familiar where the state of Georgia is, we are in the lower southeast. Georgia is the largest state east of the Mississippi River, and agriculture is the #1 industry in Georgia. In 2021, farm gate values exceeded $14.7 billion in Georgia. So it's a big deal in Georgia, especially in South Georgia. Now, if you're familiar with the University of Georgia, the main campus is located in Athens, which is about 3 hours north of where I currently sit. And I am in this county, Tift County, again, about 3 hours south of the main campus. And we are right in the heart of the agricultural production region in South Georgia. As you might have read from my bio, I am an extension weed specialist. Currently I have a 100% extension appointment. So I spend all my time trying to help our county extension agents help our farmers manage weeds in various crops. I do it in various ways. In January and February, I drive all around our state delivering what I call the weed science gospel and trying to give growers updates on what we're seeing and what we're learning. And then from about March to October, I'm in the field almost every day, either conducting research or answering text, phone calls, emails, and conducting numerous farm visits to troubleshoot related problems. I did forget to mention one thing about the location that I'm at. We call it the UGA Tifton campus. There are about 81 faculty here with 19 postdocs, a bunch of graduate students, and over 5,500 acres of research farms available to us. So you can see our state and our college has a big commitment to production agriculture and trying to keep farmers in Georgia sustainable. Now, I just wanted to mention briefly a little bit about South Georgia agriculture, because it's vastly different than a lot of places. I'm broadcasting to you live now from Tifton, if you can see my pointer, which I showed you on the earlier slide. But the thing I want you to notice is that if you just go a short drive outside of Tifton, Georgia, you'll notice that there are a lot of agricultural fields. They're not very large. I would say on average, we're probably going to have maybe 40 acres as our average size. Of course, we've got bigger fields, but when you look at the diversity, as I'm pointing here, you can just see all these smaller fields here. Typically, our fields are going to be surrounded by pine trees. But in this area, we have coastal plain soils, which means that they have low or almost no organic matter. They're very sandy. We used to be under the ocean and or a beach. We get a lot of rainfall, over 47 inches a year. We also, because of our climate, we use supplemental irrigation quite a bit. Our soils never freeze. We have a tremendous crop diversity. Our two major row crops are peanut and cotton. We are the #1 producing peanut state in the US, and we are the #2 cotton producing state in the US. but we also grow a bunch of other crops. And within less than an hour's drive, I can be in a field of any one of these commodities that I've got listed here, anywhere from soybeans to field corn to tobacco, watermelons, pecan trees, numerous vegetables, blueberries, you name it, we grow it in this area. We also have about 11 million acres of pine trees, which are grown or managed for forestry production. I do want to give a shout out to my Canadian friends. Canada is a big buyer of peanuts, so continue eating peanuts and helping to support South Georgia agriculture. Now, before I get into the meats of my talk, I didn't really know what the level would be of understanding about herbicide resistance. So I wanted to cover one thing briefly, because you hear this a lot when we talk about herbicide resistance. You hear the acronym ALS all the time when we talk about herbicide resistance. And that's basically an acronym for an enzyme in plants called acetolactate synthase. Sometimes it's called acetohydroxy acid synthase, or abbreviated AHAS. But all that is an enzyme that's needed to form certain amino acids in the plant. And obviously amino acids are important for protein and growth and all that kind of thing. There are 6 herbicide families that have that mode of action, and there are about 57 active ingredients. So you can see it's a big group of products that have that mode of action, and you'll see coming up what the issue is with that particular scenario. Now, if we're going to start talking about resistance, we have to be on the same page. What is resistance? Resistance simply is the inherited ability of a weed to survive a herbicide application to which the original population was susceptible. It's no longer responding to the doses that are applied to a particular field. Originally it did, but now it doesn't. Now, if we think about the beginnings of herbicide resistance, this is not a new phenomenon, as you will see. At least in the US, the first reported case, which was in Hawaii, the state of Hawaii, was spreading dayflower when it was discovered to have resistance to 2,4-D. And the WSSA-HRAC, that's the standardized mode of action terminology. You're going to see that throughout the presentation. So it's what we call a group 4 herbicide. And later it was 1970 in Washington, it was common groundsel, which is this species here. But since we're broadcasting to or around Canada, I just thought I'd throw this in for the Canadian folk that are listening. Your first reported case was in 1957 in the province of Ontario. It was wild carrot, and it was also resistant to 2,4-D. In Alberta, I think where we actually are, the group that's running our program is, the first weed species was common chickweed. And as I already mentioned, and you're going to see this a lot, it developed resistance to the ALS mode of action, or the group 2 mode of action. So it's not a new phenomenon. It's been around, 43 and 23s for 66 years. We've been dealing with herbicide resistance. Now, I think it's important to discuss what has happened with resistance. And if you look at when things really started exploding, it occurred in the early 1980s. And the first herbicide that was ALS herbicide that was developed was a product called chlorsulfuron in 1982. You may know it commercially as Glean or Tellar or Finesse. And then you can see that after that time, we see the rapid explosion in the number of resistant weeds that developed. All right, but that was the first ALS herbicide that was put into the marketplace, and subsequently we had and that was the start. It wasn't the cause, but that was the start of the rise in the incidence of herbicide-resistant weeds. Now, one of the things I find funny is that when we talk to groups that don't know anything about agriculture, they think that herbicide-resistant weeds fell out of the sky, or somehow we made them, but that's far from the truth. In actuality, herbicide-resistant weeds are in every production field in the world. And it's how we manage those fields that leads to the evolution of resistance. As illustrated in this diagram, it's just a simple diagram where, in this case, you have a herbicide sprayed and you see this one plant that's slightly different. would happen to be a resistant plant. It could be 1 in a million, it could be 1 in a billion, it could be 1 in several billion. And we spray that herbicide, and if we allow that plant to go to seed, that resistant plant now produces seed and places it back into the field. And then over time, as we keep using herbicides and we select for those resistant weeds, eventually we get rid of the susceptible population, and then we end up with the resistant population. And that's the problem. So again, they were already there. What we did to the field resulted in that population becoming the dominant population in that field. Now, another thing that we learned over the years is that, yes, we do have resistance in the field, and that's something that every farmer has to worry about managing their field. But we also know that the phenomenon known as pollen drift can occur, which now means a grower could be doing everything that possible to manage resistant weeds, but if his neighbor is not, and if the weed is cross-pollinated, the pollen from a resistant plant, and in this case, I'm talking about Palmer amaranth, can move from a field into another field that does not have resistance, and that pollen could cause the female to produce resistant progeny. And we have documented that pollen can move at least 900 feet, and where we could still pick up resistant progeny in a susceptible female. So what that means is that growers in an area have to start collectively thinking about how they manage their weeds and the practices that we can use to keep this problem from spreading. Now, there are different type of resistances out there. Again, I just want to give you a brief overview, and I'll get into what we've been doing for the last 20 years to help growers. But we have single herbicide resistance, which there would be resistance to only one herbicide. We have cross herbicide resistance. That would be resistance to 2 or more herbicides with the same mode of action. And then we have multiple resistance, and that would be the one that's most troublesome. And that's where we have resistance to 2 or more herbicides with different mechanisms of action. In my world, we currently have Palmer amaranth that's resistant to at least 3 modes of action. It's resistant to glyphosate, it's resistant to atrazine, and it's resistant to various ALS inhibiting herbicides. So that's the problem we've been facing since the early 2000s is dealing with a weed that developed multiple herbicide resistance over time. Now, the other thing that comes up is, what are the mechanisms that make plants resistant to herbicides? And I'm not a physiologist. There are a lot smarter folks than me that do physiology. I'm more of a practical or in the field kind of a guy. But there basically are 2 types of resistance mechanisms. The first is target site. And there are, under this category, there are different types of target site mechanisms. The first would be an altered site of action, which I'm going to get into in a minute. And then that's generally has been the most common. And then gene amplification. Gene amplification is what has occurred with glyphosate resistance, particularly in Palmer amaranth. There's also metabolic resistance, and metabolic resistance can be a little bit more troublesome because it's not well understood, and there's a lot of things going on in the plant as far as metabolism, absorption, and translocation and sequestration. And oftentimes, if you have metabolic resistance, you may already have developed resistances to herbicides that have not ever even been sprayed in a field. So obviously, a metabolic resistance is a little bit more of a challenge. Now, just a couple of quick schematics that kind of address the resistance mechanisms. The first is the altered site of action. So if you think of a plant, it has a binding site where the herbicide has to get to, and when it binds to that site, it disrupts the processes, whatever those might be. You think of it as a key for a doorway. If you don't have the right key, you can't open the door. And that's about what happens with an altered site of action. There's a change in the site of action. In this case, we have common lamb's quarters, and you can see if we have a susceptible common lamb's quarter, that atrazine is going to fit into the binding site quite nicely. If we have a resistant common lamb's quarter, that atrazine is not going to get to the binding site, and it's not going to work. The other one that's received a lot of attention over the last few years has been gene amplification. And as I mentioned, this is what's occurred with glyphosate and Palmer amaranth. And quite simply, if you look at at this schematic, it's kind of, I mean, it's very complicated, but in a simple way, at the top we have a susceptible plant where the yellow figures in there are the EPSPase enzyme, and then the red, I guess they would be squares or diamonds, that's glyphosate. So in that system, we have more glyphosate than EPSPS enzyme, and so we can control the plant. And if you compare that to the lower one, where we have a significantly higher number of EPSPase in that system, then there's not enough glyphosate to do the job. So we simply overwhelm the ability of glyphosate to control that crop, or excuse me, that weed. Again, in this case, for me, that would be Palmer amaranth. Now, let's look at herbicide resistance around the world. There's, we've heard from people from Ireland and other places. And so just quick review of what's going on in the world. There are, and as of last week, as you'll notice on the bottom, a lot of the data that we use as weed scientists is available in the International Herbicide Resistant Weed Database, which is online. So I accessed this last week. There are at least 514 unique cases of resistance around the world. If you break that down a little further, there are over 267 species. About 154 of those plants are dicots and 113 are monocots. And the top 3 modes of action that weeds have developed resistance to include the ALS inhibitors. Now, you know why I mentioned that at the beginning. There are 171 species that have developed resistance to the ALS herbicides. And these include common herbicides, again, such as chlorsulfuron, difensulfuron, imazethapyr, and many, many others. The PS2 inhibitors would be number 2, and these would be the triazines, things like atrazine or simazine. And then lastly, the EPSP enzyme, and this would be glyphosate. And there are 56 species now around the world that have developed resistance to glyphosate. Now, if you look at the top 3 countries where resistance is a problem, these are the US, Australia, and Canada. As an American, whenever the Olympics are on, we're always trying to get the most gold medals. But sadly, right now, we held the gold medal for weed resistance, which is not something to be proud of. And it's something that we're working on, and every weed scientist in the country is a top priority. But you can see the US does lead in the evolution of herbicide resistance, followed by Australia and then Canada. Now, I thought I'd just mention what's going on in Alberta a little bit, just because of the host of the conference. Right now there are at least 25 reported cases of herbicide-resistant weeds in the province of Alberta. 72% of those cases are the ALS or the HRAC or the WSSA group number 2 ALS mode of action. And there are 18 species, as I've listed here. I won't read those because that's too many to read, and there's a diverse group of weeds that have evolved resistance to the herbicides that are used in Alberta. Now, from my perspective as an extension specialist, especially now that the resistance issue is so prominent, one of the challenges we face when we look at problems is every herbicide failure that may occur in a field really resistance. And my first response to growers is, as I go look at those types of problems, would be, generally, if you have not been using that herbicide or that mode of action for several years, it's probably not resistant. So there's a lot of other reasons why herbicides don't work. Let's talk about those. But then if we come to the conclusion that you've been using the same mode of action for many years, then it's very likely that you have resistance. And we've been seeing in the US that it can take as little as 3 years for a plant to develop resistance with repeated use of herbicides with the same mode of action. And things we look for in this scenario is that if we have a patch of weeds that's normally controlled, and then now it's not, or we have healthy weeds that are mixed with controlled weeds of the same species, or if there's a patch of uncontrolled weeds that's been spreading over the past couple years. In this next picture, it's a little blurry on my screen. It probably is, I guess, around the world, but this is a slide from one of my former colleagues and mentors, is Dr. Alan York from North Carolina State. where this is MSMA resistant cucumber in North Carolina. You can see this is a classic example of what resistance looks like in a field where you've got one plant that's completely dead and then many plants around it that are not dead. And when you rule out the potential causes of that, you can come to the conclusion, especially if that mode of action has been used repeatedly, that we likely have resistance. Now let's get into the herbicide-resistant weed management plans, because as I mentioned in the beginning of my presentation, I personally have been working on this issue with growers in South Georgia since 2000, when we discovered ALS-resistant palmer amaranth, and then in around 2003, 2004, glyphosate-resistant palmer amaranth. And one thing is clear that we've learned over the last 20 years is that reliance on herbicides alone will not be sustainable in the management of resistant weeds. We've got to do other things. Herbicides are still a part of our programs, but we are trying to get growers to do other things when it fits their farming practices and their economic situation, all these kind of things. You know, it's easy for us that are making recommendations to make recommendations, but at the end of the day, our farmers have to make money. Our farmers have to make a living. Our farmers have to pay the lenders back when they borrowed money to run their operations. So we've got to make sure that the things that we recommend are practical and things that are going to keep the farmers profitable. And if we just look at a quick summary of these things, whenever we deliver a weed meeting, as I mentioned earlier, for the past 20 plus years, my colleague and I have driven all over the state of Georgia delivering meetings to growers or information to growers at over 40 meetings a year in the wintertime. So we reach a lot of our growers with updated information, but using other control tactics, and I'm going to get more specific in a minute, understanding and knowing the modes of action, that's become extremely critical and important. Rotating modes of action, and with that, rotating crops brings us that opportunity to rotate modes of action. Using tank mixtures, making applications with more than one mode of action. Using residuals, we often kid when we're talking to growers, the best way to keep a residual weed out of the field is to prevent it from ever coming up. And we only can do that with residuals and other things. Escape roguing, and you'd be surprised at some of the things we have done in Georgia to try to help that. And then probably more importantly now than ever is post-harvest weed seed management. What we do after we get crops off the field can have a significant impact in the future of weed problems in our fields, especially in our environment. For example, if I talk about weed control in corn, we're planting our field corn in March or February and March, and we're getting that corn off in July and August. And in South Georgia, we may never get a freeze. So we have an ample period of time there between, say, August, and if we were to get a freeze, it would be somewhere around the middle of November, but it doesn't last very long. We have an ample period of time there for any weeds that are left in the field to go produce seed. And that one cycle of that can ruin multiple years of doing an excellent job in a field with resistance management. Now, the first thing we talk about is tillage. And when I say tillage, some people in the audience and around the world and even at our meetings, they go, ugh, tillage. The last thing they want to do is drag out the moldboard plow to plow a field. Well, why? Well, it takes time, it costs money, right? And there are some negative effects from tillage, especially runoff, soil runoff or pesticide runoff, whatever it might be. But it's very clear that a lot of our resistant weeds, especially palmer amaranth, respond to tillage. Well, we can, if we're running out of options, and we haven't used bottom plowing in a while, that is certainly an option that a grower can consider. These are pictures that were actually sent to me from a grower and the county agent in that particular county during that year. You can see it was a while back. And so tillage is a very effective option for weeds, herbicide resistant weeds. Again, there are issues, you know, there are like anything else, there are risks and benefits to every management strategy that we potentially could use. but certainly tillage. Now, where I live in South Georgia, where we grow a lot of peanuts, in a typical rotation for us, the way that it works out, it's very likely that we will be plowing a field to get ready for peanut production. And then that field wouldn't be plowed for 3 or 4 more years after that. We only need, I guess what I'm saying is we only need to plow maybe once every 3 or 4 years. That's not something we have to do every year because obviously for erosion purposes, as well as bringing weed seeds back up to the soil surface that can germinate. So that's certainly one option. We've seen an increase in tillage. Again, there are growers that won't ever till, and so we have a little bit more challenges there when we're dealing with resistance. And if you're looking for some data, again, as I mentioned, I'm an extension specialist. I'm usually talking to farmers. I don't like to show data. I'd rather show pictures of the things we know work, but I am a scientist as well. You know, there's some data that my colleagues have collected about what happens to pigweed seed or palmer amaranth seed when you bury it. You can see down here that when we bury it, after about a 3-year period that we leave that buried, the longevity of that seed decreases. So that's one of the reasons why tillage is a good option for managing weeds. If it fits the production system and the concerns of a grower. Here's just another example. I mentioned we have Italian ryegrass that's developed resistance to several modes of action. And so we're kind of running out of options for controlling ryegrass. And we don't grow a lot of wheat. You know, we typically, I think in 2021, we might have had about 110,000 acres of wheat. I know there's a ton of wheat in Alberta, but one of the things that research has shown that like palmer amaranth, ryegrass responds to tillage. In this particular research, ryegrass was planted about a half inch deep, and then some of the field was tilled and some of it wasn't. When I say tilled, I mean deep turn, where we're actually burying the seed. And you can see there's a big difference in the emergence of ryegrass where there was tillage and where there was not. Now, another thing that we've been trying to promote is the use of cover crops, and in particular cereal rye, as a way to help manage resistance. And when I say cereal rye, I'm not talking about just slinging it out there and letting it go. We're encouraging growers to use a good seeding rate and apply nitrogen to try to get as much biomass as possible. There have been a few government programs that could help growers with some of the costs associated with this, but certainly not on a for everybody scale. Also, cover crops, it's interesting. You've got growers that are tremendous at growing cover crops. It's a science and it's an art, and the growers that do it well, but it can be difficult getting established, right? Again, you can see the benefits on the left where we have a rye cover crop that was planted in the fall, terminated in the spring at its maximum height, and then strip tilled. In this case, that's cotton that was strip tilled into the cereal rye, where on the right, there was just a weedy cover that was used. And this is in a resistant area. Right? Now, just because we use cover crops doesn't mean that we can get away from herbicides. Right? As you see in this picture, the picture on the left is a cover crop without herbicides, and that's all palmer amaranth, by the way, if you're not familiar. And then on the right, that is a cover crop with herbicides. And so we've learned over years that some herbicides work better. We use, in this scenario, which is cotton, we use a lot of reflex or foamicefin or diuron in these systems. In peanuts, we might use Valor or flumioxazin to help us. Oops. Go and get a little ahead of myself. Okay, so that's all I'll say about cover crops. You know, we also talk about row spacing, and the crops that we grow in Georgia, some of them lend themselves to narrow row spacings. There's other advantages to narrow row spacings, like improved yields. But if you look at weed control, in this case, I have cited some information about soybeans and corn, where that if you look at a bunch of research that was done, at about 64% of the time, there was less late season weed density or biomass when narrow rows were used, and this is in soybeans. And when I say narrow rows, that would be anything less than 30 inches. So by going to a 30-inch row, we had a significant benefit in terms of managing weeds, whether they were resistant to herbicides or not. It works on all of our typical weeds we might see in a production field. Again, can't just do it with that. It takes a whole system to do it. Now let's talk about mode of actions briefly, and I think I'm still pretty good on time. I usually tend to be short in my talks. Herbicide modes of action, as I mentioned earlier, it's extremely critical now that every farmer everywhere that sprays herbicides or any pesticide knows what their mode of action is. And you don't have to know the technical name for the mode of action or what the exact active ingredient is, as long as you can tell the difference between a 1 and a 2 or a 13 and a 23, you know that you're using a different mode of action. And so it's extremely important. And I know everywhere that I'm talking to, there are people sort of like me, I guess, that can help you interpret some of this, because it can be confusing if you're looking at active ingredients and plant names and enzymes and all that. But it's really simple if you just look at the numbers. And if you're spraying a 2 and a 32, then you know you got a different mode of action. Now, they may not always be labeled in the crops that you're working with, but it's very simple to understand the difference in the mode of actions. And one of the things that manufacturers have done to make it a lot easier for producers is to put the mode of action directly on the herbicide label. I've got 2 herbicides here that we use a lot in my area. One is Callisto, which is the active ingredient mesotrione. It's a corn herbicide, field corn herbicide. And then the other is Cobra. The active ingredient is lactofen. We use that in soybeans and peanuts, at least in the crops that I work with. And you can see both of those labels have the mode of action clearly displayed on the label. So now a grower can look at that label and say, all right, that's the mode of action. Let's be conscious of what we're spraying and make sure we don't overuse those modes of action that we might be applying. All right, now, as far as modes of action, there hasn't been good news about the development of modes of action. Up until the last couple of years, and forgive me, you're probably going to hear a train go by. I live in a rural area with a train track right next to my building. So if you hear a whistle, it's going to be a train that's probably less than 100 yards from where I'm speaking. But we haven't had a new mode of action since 1982. And just recently, companies like BASF and FMC have released 2 new modes of action. One could be used in rice, and the other could be used in small grains, as I've highlighted here. I think FMC has another one that's likely to come out in 2026. I don't know much about that one yet. I haven't tested it or anything, but that will be for corn and soybeans. It's interesting, if you look at the BASF product, I can remember as a young graduate student in the late 80s giving a talk about that product in soybeans, and then it kind of disappeared. And then now, lo and behold, it's made its way back into the arena, and it's being sold in Australia with a couple of trade names. It might be in Canada. I was trying to find a label in Canada, but again, we've got some good weed scientists there, so I hope that you rely on them like our growers rely on us. Now, the other thing we talk about a lot with our growers now that we didn't probably do when I was a younger man was managing the weed seed bank. And what does that mean? That means keeping weeds from getting to the seed stage where they can then drop those seeds back into the field, and then the problem is perpetuated. You can see the Palmer amaranth seed is very tiny. It doesn't take much to move that around. We know that different weeds produce different amounts of seed. There's a lot of things going on with seed. They're subject to decay from insects or earthworms or fire, in my case, fire ants. Of course, diseases, they have dormancies, they're different seed size, they emerge from different depths. So there's a lot of things going on in the seed bank, but we really stress managing weeds after harvest in fields that it's practical. And it doesn't work for every field, but there are some cases that it does. Okay. One of the things that we do, and you wouldn't believe that this occurred because it's still occurring today. When we were first dealing with the resistant Palmer amaranth resistance, we were having a heck of a time, right? And we were running out of options. And we had growers hand weeding fields. It can be very expensive. I talked to a grower the other day, and he had some hand weeding done. It cost him $15 an hour per person to hand weed some of his peanut fields. Now there weren't a lot in there, but it's become a common practice in my area that if we have a few weeds in a field, it's very common for a grower, or he will get somebody to go into those fields, pull out those weeds, get them out of the field, burn them, put them in a pile, or burn them, or get rid of them. But it's very common for Georgia farmers now to remove populations of palmer by hand before they go to seed as a way to manage herbicide resistance. Now, one of the other things that I've been trying to get our growers, especially our corn growers, field corn is one of the crops that I work with. And as I mentioned, we plant early and we harvest early. So that gives us a long period after harvest that if we let those fields go fallow or don't plant a cover crop, whatever it might be, those fields can get a whole nother flush of weed seeds produced. And of course, we could use tillage, right? We could use cover crops, but a lot of folks want to think about herbicides in some scenarios. And so we've been trying to get growers to think about managing, particularly palmer amaranth. And we have another pest called Bengal dayflower that we're trying to get a handle on, and we want to manage that in the fall as well. So in this case, I'll just show you a quick picture. This is from one of my research areas. This was a field of corn that we harvested. And then we came, and you can see there's a lot of volunteer corn in there. There's some pigweed in there, a bunch of grass. And if we let those go to seed, we got more weeds, right? So I went in on this day and I sprayed a combination of paraquat, or it's sold as under the trade name of gramoxone, and and tricor, which is metribuzin. Both are older chemicals, but they still work very well for us in South Georgia. And I sprayed that area to show growers what we could do in the fall. And then when you look at that field 28 days later, now those strips you see in there were left on purpose. We left some checks in that field to kind of show the difference between control and no control. And you can see that that program was extremely effective in burning down those weeds and keeping those weeds clean until we decide to do something, whether that would be planting a fall cover crop or whatever else it might be. So again, something we really try to get growers to do. Sometimes it's a hard pill to swallow, because if you think about making an application after a herbicide application after the field's been harvested, you're not really gaining any value there in terms of return on your money with a crop, but you are gaining value in knocking back the population of weeds that are in that particular field. All right, what about other options? You know, I'll be honest, I've talked a lot about herbicides. I've talked about tillage. I've talked about cover crops. And the point, again, that we want to stress to growers is that it is not one thing that's going to solve the herbicide resistance problem. It's going to be an integrated approach where we combine as many practices as possible. And so a lot of my colleagues around the country haven't delved into this area yet, primarily because the main crop that I work on is peanuts, and some of these things don't work well for peanuts, like seed destructors, for example. We've got too many holes in the peanut combine that would allow weed seeds to fall out before they ever got to the back. So that's kind of why I've not worked on it. But you know, you can look around. There are seed mills, and these would be placed on, and that would be two examples right here. They'd be placed on the back of a combine, and as the chaff goes through the back of the combine, those seeds are basically mashed or destroyed, and then they're no longer going to be a problem for next year. What I've got a picture of here is chaff lining. That's where, instead of mashing the seed, you concentrate the chaff into a smaller area. And from what I've read, instead of broadcasting seed all over the farm or that particular field, we're now concentrating it into a less than 10% of the field. And so maybe we can better manage those weeds. And I have the costs, the rough costs associated in there. These are American dollars, so you can figure it out if you're from another country, I hope. Then the one on the right is, and I've never done any work with any of these that I'm showing you. I'm just telling you that various colleagues are working with all these to try to come up with other options. The weed seed destroyer, which uses a combination of heat and blue light to hurt weed seeds. We've got a weed zapper here that uses electricity, for example. And one I recently learned of is this particular unit is called a crop zone, where it uses, again, electricity and some type of fuel or liquid that goes on the plant to enhance the activity of the electrocution. So there is a lot of work going on in this area by a lot of people, not only in the US, but all around the world. All right. The other thing I want to mention briefly, because this has caused some of a problem in the past, is what rate do we use, and does the use of reduced rates influence herbicide resistant development? You know, as I mentioned earlier, growers ultimately have to make a profit and then make a living to keep going, and they can't afford to spend money that's not going to bring them any return. And so back in the, I would say the late 80s or so, there was kind of a push to look at lower rates. And, you know, we didn't really need to get 100% weed control to get optimum yield. Those kind of things were going on. And so we had some lower rates go out. But since that time, we found out that if we use a lower rate, and sometimes you might hear this referred to as creeping resistance, where if we use a low rate and you get a survival of some plants, those plants could have minor genes already that have resistance. And it's also possible that sublethal rates, or rates that don't kill a population, can enhance mutation frequencies. And that's what it's all about, is the genetics of the plants. So we're only recommending full labeled rates now. And we know that the use of lower than normal rates or label rates help contribute to the problem. So I'm just going to almost finish up there here. I maybe got us back on time, but I never like to take all my time, because I'd rather answer questions if I can. It's just to remind you there is hope. We have been able to deal with resistant weeds. I think we've been fortunate in the Southeast, in my state, that we have some crops that we rotate to that give us an opportunity to diversify tillage, row spacing, the use of cover crops, and multiple modes of action, which has kept us in the game longer than some other states, perhaps in the South, in the Mid-South, that may not have those opportunities. So, you know, rotating crops, and with that comes rotating modes of action and understanding what the modes of action are. The most important thing we tell our growers whenever we deliver a program to them is to start clean. And we can use tillage, we could use cover crops, we could use herbicides, we can use a combination of all three. But we know that if we don't start clean, it's very likely that we will be battling weeds the whole year, spending a ton of money and probably not making as much money. I know we won't be making as much money if we started clean. Using narrow rows when it fits the crop, using full labeled rates, using herbicide tank mixtures, using multiple residuals, preventing weeds from coming up before they even start, being timely with our post-emergence herbicides. We can't let weeds get big. Hand weeding escapes, using other things like I mentioned on combines that could help destroy weed seed, and managing the seed bank. All of these things together have helped our growers manage resistant weeds. Again, it's not been easy. It's been a struggle as we've transitioned. Again, if we had growers that weren't tilling for a while, you know, getting them to maybe pull out their moldboard plow in a field that's really bad. Ultimately, we may have talked them into it. And again, as I mentioned, we don't recommend that every year. That's probably 1 every 3 years that we'd like to see a plow in the field where we've got a major resistance problem. If you're looking for more information, probably every weed scientist on the planet is working on resistance. So wherever you're located, you probably have a local expert. If you don't, just get online and look them up. There are 2 good places to get information about resistance. One is the Herbicide Resistance Action Committee, the HRAC, and I have the site listed there. And where I got a lot of my statistical information about the evolution of the distribution of weeds came from the International Survey of Resistant Weeds, and that's online, and that's updated almost, I don't want to say every day, but almost every day somebody's adding something to that list in our knowledge base. With that, I'll stop my presentation. I would be happy to answer any questions. Feel free to check out our website at gaweed.com. I've got my email listed. I've got my cell phone listed. Always happy to visit with anybody that wants to learn more about weeds and what we're doing in South Georgia. Here's just I mentioned to you earlier about our field size, and that our fields are often surrounded by pine trees. This is one of our better corn growers, actually, that I was on his farm that particular day when he was putting out some burn downs, I believe. And you can see the field's not that big, and there are pine trees around it. So that's a typical scenario in a lot of our locations. with that, I'll stop sharing. And I'd be happy to try to answer any questions. Again, I appreciate the opportunity to visit with everybody. And if you're not sure what's behind me, that's actually a peanut combine in the field. I had a research test on that grower's farm a couple of years ago. But anyway, glad to visit with you. And I can't tell, or Jamie, I don't know if anybody's asked questions or not. I can't tell at this point.
Okay, I don't see any questions that have popped up so far, but if anybody has questions, feel free to turn your camera on. You're welcome to ask your question yourself, or you can just ask it without turning your video on. That's fine too. And again, if you're too shy to do either of those, feel free to type it in the chat. I'm happy to pose the question to Eric. While you guys are thinking, I guess I'll start off the conversation. How do you think the US ended up #1 overall in weed resistance? Is there anything in particular that you think maybe contributed? Or
Well, that's a great question. In my career, I've been in 3 different parts of the US in different roles. I've been in the Northeast and the Southwest and the Southeast. And I would say in general, most American farmers think the same. So we kind of think the same way wherever we are, regardless of the crops that we're growing. And so, there's just a culture of the way things were done. And that's the way we were doing things. And then maybe didn't really understand, nobody really understood how fast it could occur, and economics play into it. If you think about glyphosate, the development of glyphosate resistant crops, that made it a lot easier for farmers to manage weeds. And so there were a lot of things that contributed to it across the US. We're not proud of that. I can assure you, but we have to deal with it. And our growers are committed. Our farmers want to stay farming. So many of the growers that I work with have been here. They're here on land grants from the King of England. So their families have been here for several hundred years, and they want to stay that way.
Perfect. George, you have a question?
Yeah, thanks, Eric, for your presentation and the information. I guess a question or an option for managing herbicide-resistant weeds, when I've used in the past, is livestock. Now, I don't know if you have access to ruminant livestock, beef, cattle, dairy in your area, but definitely taking a crop off as a silage forage crop has definitely helped in my experience with reducing especially the seed bank.
Are you a dairyman?
No, I'm actually a crop consultant. I have about 20,000 acres, mostly beef and feedlots.
So we do have dairy here in Georgia. Of course, our climate, we're kind of hot and humid, so that puts a lot of stress on the dairy cow. But we do have. I work with a couple of dairies. In fact, one of the dairies, the larger dairies that I work with, was one of the epicenters for resistance. So I've spent a lot of time on their farm, trying to help them manage their particular problems that are coming up ways. So we do have some, but where, again, I think I showed you in the beginning, where I live and the growers that I work with. Some of those guys might have some beef cows, but mostly I'm dealing with growers that are crop growers and not livestock people, although everybody might have a couple of cows. But we do have growers that are just livestock growers and growers that are just crop growers. One of the things that I've observed with dairies, and I was a county extension agent in the Northeast in a county that at one time had 22 dairies. They're no longer there. One of the things that always not troubles me, but just this fact of life, is that on dairies, usually their focus is going to be on the cow and milk production, and not weed control. Now that's not every dairy. I'm not saying that about every dairy, but their main goal is to get milk, all right, and keep cows healthy. And so a lot of times the crop protection side takes a backseat to the needs of the animals. And again, that's not every there are I know a lot of dairymen that maybe that's a brother operation or a family operation. One grower will take care of the cows and the other will take care of the crops. That works out pretty good. But in a lot of cases, the cows come first, and that can affect how we manage weeds.
Thank you.
So there was a question that's been asked on Feed Loop, and it says, he's asking, do you think weed resistance knowledge transfer in the US would be successful if not for extension work? But I'm going to change the question slightly and ask, what is the most effective knowledge transfer system that you've seen
Well,
in sharing information?
Well, it's interesting, if you're not from the US, traditionally, the way that it worked was we have land grant colleges like the University of Georgia. And then part of that mission, it's teaching research and extension was to develop, take that information out. And over time, there's been a watering down of that system in other states. Fortunately, in my state, we still have a county extension agent in every county. We have 159 counties in Georgia, and there's a county extension agent in every county. And so we still have a very strong presence in the county. We have good rapport with the growers. And so in my state, that's still one of, if you look at some surveys that we have done recently, we're still the #1 source of information. So that's good. We're losing ground. Obviously, there's a lot more going on in industry in some other states. If you look at some of the bigger states where they've consolidated their extension systems, maybe they have regional agents now, they've lost a little bit of street cred. And it's hard to get that back once you lose a client. If you're an industry person, once you lose a client, it's hard to get that back. But we've been lucky here at Georgia to continue what I call the traditional system, where we have a county agent in every county and a team of specialists backing them up. And we work closely with consultants. I don't see a consultant as an enemy. I see them as an ally because they're in the field a lot. We're all on the same team. We all like to eat food and we like to have clothes, and so we're all ultimately on the same team. So, I try to work with everybody as possible. And, certainly there's no doubt that industry has taken over some of that role in other states, having their own agronomists, their own research facilities, those kind of things. But truly one of the benefits of the land grant system is that I don't sell anything. I can make recommendations without, I want to make the best recommendation possible. It doesn't matter whether I sell 20 cases of product A or 500 bags of seed of this. I want to make the best. Now, it may come to that. It may be something that benefits a company, but it doesn't benefit me. All I care about is giving growers the best possible answer for that situation. I'm lucky. I'm lucky that our system's still that way. It's been eroding in the U.S. And it's sad because it's been a great system, and I'm lucky to still work in one that works like it's supposed to.
All right, and we have a question in the chat here for Zoom. Mike's wondering about implementing strategies to manage weed resistance. Can we ever get back to the good old days before there was resistance, or now that it's here, is it here to stay and we have to alter our plans?
Well, that's a great question. Well, I can tell you we've been dealing with it for 20 years and it's not going away. So it's lasted at least that long. I don't know that we'll ever be able to get rid of it. Some of these weeds have long longevity in the soil. So that's always an issue. But I do think that we can make it better. Now that I think we're better stewards of the whole system than we were before. And we can hopefully learn from the mistakes that we made to try to keep it from getting worse. Ultimately, Mother Nature will win every fight, right? That's history has shown that. But we can, man's always in the way of Mother Nature. But I think we can do better than we're doing now. We're doing good. We can do better. We can slow it down, but I don't know that we'll ever be able to get rid of it. It'll be a little monkey on our back probably for as long as I live.
All right, we've got just a couple more minutes. If somebody has a short, quick question, we can take one more and then we'll wrap it up. I will add the QR code now though, so if anybody wants to scan it, it'll come up shortly.
I'm trying to get my G in there for a little. Thanks again for the opportunity. I appreciate visiting with you, and hope you've learned something from the experiences that we have in the Southeast.
Yeah, thank you so much, Eric, for your presentation. Really enjoyed it. Definitely interesting to see different parts of the world, how they're managing, because we all end up in the same position at some point, it feels like. So it's good to know, some of the states.
Ultimately, we are all on the same team.
Yeah, exactly. All right. Any last minute question? Perfect. If you need to grab a refreshment or take a quick bio break, feel free. We're going to wrap it up here in a minute and say thank you to Alpine and Hanlon, 2 of our 2022 program partners. If you guys have any questions or having any technical difficulties, make sure you're reaching out to a team member, and we'll resume here at the top of the hour. So just a couple of minutes with Phil, and he's going to give us some information on nitrogen fixing bacteria. I'll see you soon.